So we would like to give the generating function for odd partitions. And basically, let's recall that we call a partition odd if the numbers that the components of the partition are odd numbers. So let's say for 5, this would be an odd partition into ones, or 1 plus 1 plus 1 plus 3, or simply 5. So these are the 3 odd partitions that we have. Let's recall that the formula for all partitions is given by this impressive formula of Euler's, the generating function for all partitions. And what we would like to ask here is, what should we put on the left of this equality, or if there is something to put on the left of this equality, so that we get the odd partitions here. So this is amount of odd partitions of n. And as usual, the understanding is that the number of the number of odd partitions of the number 0 is 1. And here, actually, it's not too hard to understand what should happen. I mean, if we recall how we obtained the partitions of all numbers, or the partitions to begin with, we will realize that all we need to do is skip the products that, or skip the sums that correspond to even numbers. So remember that we started by considering this infinite product of infinite sums. And this keeps going, of course. And we remember that here you think of 2 as 1 plus 1, and here of 4 as 2 plus 2, and of 6 as 3 plus 3, and eventually that's how we encounter the repeating components in this context. But the most important thing to understand is that if we don't want any even numbers to show up as components of a given partition, all we need to do is just skip the even parts. And that gives us a very nice answer for what we should put on the left here. So what we should put on the left is simply the product that has all the components that have an odd exponent. So 1 minus q, and the easiest way to represent this is 2n plus 1. Because when we write 2n plus 1, think about it. Start from n equals 0, that will give you 1, n equals 1 gives you 3, n equals 2 gives you 5, and so on and so forth. So that's the formula that we wanted to have. This is the number. This is how one can describe the generating function for the odd partition. Thanks for watching.